Okay, so our goal for today is we're going to be talking about rhombi, rectangles, and squares. So it says we're going to apply properties of special parallelograms. So these three figures are still considered parallelograms because we would say the opposite sides are parallel. So they still have all of those parallelogram properties, like the opposite sides being parallel and congruent. The opposite angles are congruent, consecutive angles are supplementary, and then the last one is the diagonals bisect each other. Okay, now there are going to be some new properties for each figure. So we're going to fill those in on our notes as we go. Okay, and like this first one right here, it says a rhombus. And a rhombus, what I want you to fill in is this is a parallelogram. So you can write parallelogram with 4 congruent sides is what we're going to fill in for a rhombus. It's a parallelogram with 4 congruent sides. We can still draw it as a tilted figure, and what we're going to do here is we're going to mark that every single side has the same measure. So if this side is 3, that means this side is 3, and this side is 3, and this side is 3. Okay? For a rectangle, it's going to be a parallelogram with 4 right angles. Okay, so what I'm going to do is I'm just going to draw in this rectangle right here, and then you think about, how do I mark a right angle on a diagram? Well, it's got those little boxes in the corners. Okay, so that's our rectangle. Still has all the properties of a parallelogram, so opposite sides congruent and all that good stuff. Okay, a square is actually going to be a combination of both the rhombus and the rectangle. What that means is it's a parallelogram, so it still has the parallelogram properties, but this one has to have 4 congruent sides and 4 right angles. Okay, so if I draw a picture of that square, it's going to have 4 congruent sides. It's also going to have 4 right angles right here. Okay, so there's our 3 figures that we'll be talking about, our special parallelograms. Okay, so down here it says ABCD is a rectangle, and part A says that we are going to find AD and AB. So on this rectangle, AD is across from BC. They should have the same measure. This answer would be 9. If they're asking me to find AB, what would AB be the same as? It's going to be the same as DC, so it's going to have a measure of 12. Okay, so that's not anything new. We talked about that with parallelograms. The new part would be find the measure of angle A, the measure of angle B, and the measure of angle C, and measure of angle D. Well, if it's a rectangle, look back at that definition. What does it say? It has to have 4 right angles. So what we're going to say is that each of these angles have to equal 90 degrees. So these 4 angles right here equal to 90. Okay. The next one says RSTU is a square, so it asks you to find UT, RU, and US. So if I'm looking at these, UT, RU, and RS, those are just the sides, and on a square, all the sides are the same, so we're going to fill them all in 7. Okay, and then the next piece says find the measure of angle R, angle S, angle T, and angle U. Well, that's where we have these 4 right angles right here. So just filling in those right angles, these all are going to equal 90 degrees each. Okay, the last one says PQRS is a rhombus. Find the measure of QR, SR, and SP. Well, on a rhombus, all of the sides are congruent. So if this side is 6, then this side is 6, and this side is 6, and this side is 6. So that's just using the definitions of each figure. Okay, on the next page, what we're going to look at is it says the rhombus corollary. So it says if a quadrilateral has 4 congruent sides, then I can say it's a rhombus. So it's really what we talked about on the last page. This one's just saying if they give me a figure and they mark it like this, then I should assume it is a rhombus because it's showing it has 4 congruent sides. Next one's the same idea. If I have this 4-sided figure and they mark that these 4 angles are right angles, then I need to assume that it is a rectangle. Okay, and then the last one, the square corollary, just says if a quadrilateral has 4 congruent sides and 4 right angles, then it has to be a square. Okay, so what that says is if I have a picture that's marked like this, and they also have these, I'm going to assume this is a square. So number 4 says use the information in the diagram to name the special parallelogram. So letter A, what do you think letter A would be? Okay, best guess. the letter A is going to be a square because it has 4 right angles and 4 congruent sides. Letter B, I'm seeing that I have these right angles right here, but what I'm seeing is that the sides actually have different measures, so this is going to be a rectangle. Okay, letter C, I see that I have all of these sides congruent, and if all of the sides are congruent, this is going to be a rhombus. Some students would say, well, if it has all congruent sides, then it's a square. But remember, the square has to have 4 right angles and 4 congruent sides. It has to have both pieces. So this last one right here would be our square. Okay. On the next piece, these are theorems that go with each figure. So we're going to start talking about the diagonals of the figures. The first one says the diagonals of a rhombus are perpendicular to each other. So if you think back, perpendicular lines, they're going to meet, but when they meet, they're also going to form right angles. So you can mark 90-degree angles in here. Okay, so if 4 sides are congruent, I also know that the diagonals are perpendicular. Okay, as far as the rectangle, okay, so it says the diagonals of a rectangle are congruent. What that tells me is that the length of AC has to be equal to DB. They'll have the same measure. Now, the diagonals also still bisect each other. So one thing that's kind of unique here is that each of these smaller pieces will actually be congruent to each other. They bisect each other, but they're also all congruent. So if this piece here was 5, then the rest of the segments on the inside would be 5 as well. Okay, the last one says the diagonals of a square are perpendicular and congruent. Okay, so just like when we talked about classifying it as a square, it had to have the property from a rhombus and the property from a rectangle. So the same thing happens when I talk about those diagonals of the square. If I draw in the diagonals here, I can assume all these smaller pieces are congruent. The other thing I can assume here is that I have 90-degree angles around the center. And I'm sorry, those look so silly. Okay, all right, here we go, moving on. So it says, if ABCD is a rectangle, and they tell us that A to E is 5, let's see if I can label this, okay, A to E is 5, and B to C, so this side over here is 6, D to C is 8. They want us to find AC. So AC is going to be like this full stretch right here. I know A to E was 5. That means E to C is 5. So the full length for AC, I'm going to fill in as 10. The next one says finding BD. Well, if it's a rectangle, what did we say? We said the diagonals have to be congruent if it's a rectangle. That means that DB is going to be the same as AC. It's going to be 10. The next one's going to be AD. Well, AD has to be the same as the side that's opposite of it. So AD is the same as this side over here. It's going to equal 6. And then the last one, AB, is opposite of this side down here. It's going to measure 8. Those are properties of a parallelogram that we covered earlier. Okay, letter B says, if BD is 3x minus 7, let's see if we can label this. So here's my BD, and we're going to say that it's 3x minus 7. And then it says C to A, so this stretch right here is going to be x plus 5. Okay, not a great way to label those, but that's all I can do. Find the value of x, BD, and AC. Well, if the diagonals are congruent, that means that we're just going to set them equal. So we're going to say 3x minus 7 is equal to x plus 5. Sorry about that. Okay, so when we solve here, we're going to subtract x to get the x's to one side. And when we subtract x, we're going to be left with 2x minus 7 equal to 5. My next step would be adding the 7 over to the other side. And now I'm going to have 2x is equal to 5 plus 7 gives me 12. When I divide by 2, my x value is equal to 6. So the other pieces they asked me to find here, well, they asked for BD. And BD, I'm just going to go back and substitute it in. So BD was that 3x minus 7. So if I take 3 times 6, that gives me 18. And 18 minus 7, I'd get 11 here. Can check it with AC. AC should come out the same. So if I substitute in 6 for the x, I get 6 plus 5, which gives me 11. And those are my answers for this one here. Let me double check that there's nothing further down on the screen. Nope. Okay. Moving on to the next example problems. Letter G, or number 6 says GHJK is a rectangle. Find them, and the measure of angle 1 is 37. Find the measure of each other numbered angle. Okay, so we're going to fill that in on our diagram. We're going to fill in angle 1 right here as 37 degrees. Now, we can actually get to all the rest of the angles. If you think back, a rectangle, the definition of a rectangle is that it's a parallelogram with 4 right angles. So what that means is angle 1 and angle 2 together have to equal to that 90. So if I want to find the measure of angle 2, I'm just going to say 90 minus the 37, and that's going to leave me with 53 degrees here. Okay, so I can fill this one in as 53, maybe. 53. Okay, from there, let's see here. I could fill in angle 4 because these two angles are alternate interiors, and alternate interiors have to be congruent. So we're going to fill in angle 4 as 37 degrees. Okay, and from here, something that was unique about that rectangle is that the diagonals were congruent. So do you remember when we said that all of these smaller segments here have to be congruent? This is kind of cool. So what's going to happen here is it's going to create a triangle with 2 congruent sides. And if you guys think back to first semester, if it has 2 congruent sides, that means it has to have 2 congruent angles. So what that tells us is if this angle 4 down here was 37 degrees, that means angle 3 is going to be 37 as well. The angles that are across from those congruent sides have to be congruent to each other. So the measure of angle 3 will be 37. I can then get to the measure of angle 6 using the idea of a triangle. Well, a triangle has to equal to 180. In that triangle, I have the 37 and the 37. So if I add those two angles together, it's going to give me 74 degrees. So if I subtract 74 from 180, I'm going to be left with 106 degrees for the measure of angle 6. Okay? I could get to the measure of angle 7. Angle 6 and angle 7 together from one side of the line to the other, it's a linear pair. They have to equal to 180. So if I take 180 and I subtract 106, I'm going to be left with 74 degrees for angle 7. The last angle I need to fill in is the measure of angle 5. Okay, so if I kind of look at my picture, I see that this angle right here was 37. I could fill the 37 in up here. And then once again, bringing it back to the idea that it has to have 4 right angles. So I'm going to say 90 minus the 37, and we're going to be left with that 53 degrees. Okay, so on a rectangle, if they give us one angle, we can actually fill in all of the rest of the angles on that diagram. Let's see here. Find the measures of the numbered angles in the rhombus below. So rhombus has to have 4 congruent sides. The other thing that we know about the rhombus is we said that the diagonals are perpendicular. Okay, so think about diagonals perpendicular. That means that when they cross, they're going to form these 90-degree angles right here. So what that gives us here is that the measure of angle 2 has to be 90 degrees. Okay, something else that we should mention about a rhombus, I don't think it was mentioned earlier in the notes, but you could add it here if you want to. On a rhombus, it's something with the diagonals. The diagonals are going to bisect the angles. Okay, so it's going to bisect the angles. What that's going to help us with is, well, when this diagonal comes through, notice how I have 58 on the right hand side. Well, I would also have 58 over here. If I have 58 over here, that means the measure of angle 3 has to be 58 degrees because those are alternate interiors. And since we still have, angle 3. Since we still have parallel lines, alternate interiors are congruent. Okay, so we've got angle 2. We could then get to the measure of angle 4 using that idea of the triangle again. In this triangle, I have 58 and I have 90. So if I go the measure of angle 4, a triangle has to measure 180 degrees. I'm going to subtract out the 90 and the 58, which is 148 degrees. What I'm going to be left with here then is going to be 32 degrees. Okay, and if angle 4 is 32, that also means the measure of angle 1 is going to be 32 because I just stated right here that the diagonals bisect the angles. Okay, All right, here we go. On number 8, it says ABCD is a rhombus. They give me that P to B. So P to B is going to be 12. And AB, so this side is 15. The measure of angle ABD. So ABD, this angle right here is going to be 24 degrees. Okay, find each measure. Okay, they want me to find AP. Ooh, that one's going to be tricky. We'll come back to that one. How about CP is going to be on the same stretch, okay? DP we can actually fill in right away. It's going to be the same as that PV, so we're going to fill in DP as 12. And then they're asking us for the perimeter of ABCD. Well, perimeter, if it's a rhombus has 4 congruent sides. So what that means is if this is 15 up here, it's also 15 over here, and 15 here, and 15 here. So perimeter is the distance all around. I can say 15 plus 15 plus 15 plus 15, or I could just say 15 times 4. Our perimeter is going to be 60. Okay, let's see here. AC, we'll come back to that one. Let's look at the angles. The measure of angle BDA. So if I go from B to D to A, it's this angle right here. Okay. I have this 24 up here, and that would be alternate interior to this angle down here. On that last slide, we just said that the diagonals bisect the angles. That means that this angle right here is going to be 24 also. Okay, next one says angle APC. Angle APC, that's going to be, I'm guessing that's a typo. Let's just change it to APB for right here. Okay, so APB, this angle is going to be a 90-degree angle right here because the diagonals are perpendicular. And then the last one says find the perimeter of triangle APB. So we're going to go back to these ones right here so that we can find that perimeter, okay? I'm going to erase some of this stuff on the diagram just to clear it out a little bit so it's not so messy, okay? So things that we want to fill in, this was 15 right here, this was 12, and we just said this angle was 90. So if I want to get to this side AP, we're going to bring it back to first semester when we talked about Pythagorean theorem. This is a right triangle, so I can find the missing side of that right triangle by using Pythagorean theorem. Okay, so what I'm really finding here is AP. I'm going to draw my work down here. Okay, so I'm going to say x squared plus 12 squared is equal to 15 squared. So the biggest thing with Pythagorean theorem is you want to make sure that your hypotenuse is at the end. Hypotenuse is that side that's across from the 90. Okay, here I'm going to get x squared plus 12 squared. 12 times 12 is 144. Equal to 15 squared gives me 225. Okay, from there if I subtract the 144, I'm going to get x squared is equal to 225 minus 144 gives me 81. Okay, my next step from there is I need to take the square root of both sides, and I find that x is equal to 9. So what that gives me is AP is going to be 9. Well then, if AP is 9, what is CP? You got it, it should be 9. Okay, it also asks me for the length of AC. Well, 9 plus 9 gives me 18 here. The last thing they're asking for is the perimeter of APB. So if I kind of trace this APB, one side was 12, the hypotenuse was 15, and we just found that missing side to be 9. So if I say 9 plus 12 plus 15, that's going to give me 36 for the perimeter. Okay, lots of stuff going on in this problem. That's kind of a tough problem. Okay, all right, textbook assignment for today. So textbook page 328, numbers 1 through 12, 14 through 22, 27, and 28. Hope to see you guys soon. Bye.